Hi, this video is going to be looking at two ways of actually visualizing the output of audio from Mac's MSP. And this uses two of the objects which are in the audio sort of package, which is fairly near the top of the one. We have scope and we also have spectros. Now the scope object basically gives us, if we sort of drag this over, into here, and we have connected this up to the output of here. So a brief overview of this sketch would be that we've got a numeric variable there which is controlling the frequency of a cycle, so that's outputting a sine wave, and that sine wave goes into our live gain, which means that we can set the amplitude, we can reduce the gain or we can increase it, and then the output of that is fed directly to the scope object, and it's also the same output is being fed to our spectros object. So I shall move this sort of down. So on the left hand side here is the scope object, and this gives us very much what we would see if we were to connect our sine wave into a oscilloscope. So it shows us the frequency and the amplitude. Now, because this is running at a very fast level, we won't be able to actually see the individual oscillations of a waveform. But you'll notice the amplitude. If I increase the gain, then the amplitude of the sine wave increases, and then if I reduce it, the amplitude on the scope reduces there as well. So the scope gives us a time domain view of our audio, and on the right hand side here we have a spectros, and this gives us a spectral view of there. So this is a bit like a graphic spectrum analyzer. And what it will do is it will show you how much energy is in this signal at various frequencies. So because this is a sine wave, we have only got one we'll only find energy in one frequency band. But if I change the frequency, we won't be able to hear anything because it's not actually plugged directly into the audio. But if I change this, if I put it something quite big, we can see that the audio sort of changes there. So this gives us our frequency domain, and then we've got our time domain on this one. So essentially the spectros is like a fast Fourier transform view of some sort of audio.